This is our lesson number 32. That means Spinel part 3 in this Sapphire Kingdom Gemology YouTube channel. I invite you to enjoy these contents with me. We are learning more about the spinel. This is blue cobalt spinel. We need to understand very well about cobalt spinel and Ghano spinel. That's the reason I prepared this lesson. If you forget to subscribe, please subscribe and give like and share. Now we are moving to lesson. Here it is gahnite or gahnite. Gahnite comes, the name comes with zinc. The metal zinc comes with the spinel. Then it becomes gahnite. Spinel species that can be transparent, but gahnite is an uncommon. Gahnite is also called zinc spinel. Remember, zinc spinel, zinc-rich spinel means gahnite. Is another spinel species that can be transparent, but gahnite is an uncommon mineral and rarely seen as a gemstone. It is rarely seen as a gemstone. It has a high refractive index. Ri is 1.79 up to 1.82 due to the high concentration of zinc in its chemical makeup. That is the reason that Ri goes up. Cut gems are typically dark green and can appear black in reflected light. The green color is not due to the transition metal zinc, but instead to iron-iron, that means ferrous-ferric charge transfer. That is the reason for the green color. Ferrous-ferric charge transfer inside the gemstone. Blue gahnite crystals colored by traces cobalt have also been found in Nigeria. Gahnite can be strongly magnetic. This gem is strongly magnetic. Magnet can attract these gemstones. Gahnite can be strongly magnetic, again, not because of zinc, which is diamagnetic. Zinc is diamagnetic. Zinc is not a magnetic metal, but the iron is magnetic. So due to iron, the magnetism is due to iron content in the stone. Shown below, gahnite green in reflected light. It is in reflected light, green color gahnite. And the transmitted light, it is like this. So the difference. This is 0.57 carat Brazil stone, gahnite. This is transmitted light. It gives green color. Then rare dark blue spinels. You know spinels, dark blue spinels are called Ghano Spinels. When they are intermediate in composition between spinel and gahnite. Between spinel and gahnite, there is a rare stone called Ghano Spinel. But most dark blue gem spinels are not Ghano Spinels. But in our gemological labs, they are giving Ghano Spinel, but they don't know what is that. It is a spinel, not the Ghano Spinel. If it is Ghano, the Ri must be in between this range, 1.735 up to 1.79. If it is below this, it is not a Ghano spinel. So remember it. I saw a lot of times gemologists give Ghano spinels below this range. Some are light blue spinels can also contain a high enough concentration of gahnite, that means zinc, to qualify as Ghano spinels. Because zinc raises refractive index. Ghano spinel is easily distinguished from other blue spinels by its higher refractive index. This is the range you have to remember. If the Ri is not in this range, that is not a Ghano spinel. It is mistakenly done by the gemologist. The unusual dark blue spinel of unknown origin shown below is a color change spinel. This is color change spinel. Unusual dark blue spinel, unknown origin. It is color change spinel, changing from blue to purple, blue color to purple in incandescent light. Chromium content is likely responsible for the color change. For this color change, reason is chromium content. But this gem shows no chromium or cobalt fluorescence under UV light. Under the UV light, it is not showing the red color because this gem shows no chromium or cobalt, no chromium or cobalt under the UV light. Remember that also. Then the next one is magnetic testing. This is a magnet, powerful magnet. These are the spinel stones. Then magnetic testing means this. Magnetism in gemstones, an effective tool and method for gem identification. It is nice gem identification tool. Microscopic examination reveals no definitive natural inclusions in this spinel. Magnetic testing with flotations. Magnetic testing with flotation reveals that the gem is moderately magnetic. Something we never encounter in synthetic blue spinels. Synthetic blue spinels never attract to the magnet. This simple test tells us the gem is natural. Remember, natural and synthetic, we can separate it with the magnetic testing. Natural one is different than the imitation. Synthetic blue spinels are also easily distinguished by pink fluorescence. Pink fluorescence under lone wave UV light due to cobalt in the absence of iron. No iron, but cobalt is there. So synthetic blue spinels are showing pink color under the UV light. Lone wave light, not the short wave, lone wave. Flame fusion type, it is a method of synthetic making method. Flame fusion type synthetic spinel also have a slightly higher refractive index. Like this. Approximately 1.73 than natural spinels 1.72. This is the difference. Flame fusion version is little bit higher. Then see, look at the spinels here. All our spinels are attracting to the magnet. The topaz is repelled. When the magnet comes to the close of the topaz stone, it is repelled. This is attracting. Spinels are attracting, topaz is repelling. This is natural dark blue spinel, Sri Lanka. Now, we are moving to cobalt spinels. Cobalt spinels are rare, and most blue spinels that are marketed as cobalt cobalt spinels or cobalt blue spinels are actually common blue spinels colored primarily by iron. Those are not cobalt spinels. I saw it in Sri Lanka. There are a lot of certificates and the stones, but they are telling cobalt spinels, but those are not cobalt spinels. Remember this thing. Cobalt spinels are rare, and most blue spinels that are marketed as cobalt spinels or cobalt blue spinels are actually common blue spinels colored primarily by iron. When cobalt ions replace magnesium ions in spinel, they produce only pure blue color rather than gray blue or green blue. Remember this. When cobalt ions replace magnesium ions in the spinel stone, they produce only pure blue color rather than gray blue or green blue. Pure blue color in a natural spinel is a sure sign that the gem is a genuine cobalt spinel. That color is this, electric blue. This is from Vietnam. The Chelsea filter is, this is the Chelsea filter. Chelsea filter can recognize the cobalt color spinels. We can discuss it. High cobalt content also causes spinel to appear bright pink under a Chelsea filter. When we saw under this Chelsea filter, cobalt spinels give pink color. High cobalt content is the reason. It gives pink color. Or even bright red, sometimes bright red, pink or bright red, when the concentration of cobalt is high enough. If the concentration of cobalt is high, it gives red color. If it is low, it gives pink color. Cobalt spinel is also fluorescent pink or red under lone wave UV light. Under the lone wave UV light, cobalt spinel also gives pink or red color. Right. Now you know the Chelsea filter. We need the Chelsea filter to identify that. The vivid blue, that means cobalt blue. That means cobalt spinel. The vivid blue, that means electric blue, cobalt spinel. This is the color. On the left is colored predominantly by cobalt. This color gives with the cobalt. But iron is also detectable with the spectrometer. When we check with this spectrometer, iron and little amount of cobalt and little amount of iron we can recognize. This cobalt spinel is weakly magnetic. This one is spinel, but it is weakly magnetic. SI is 55. The magnetic attraction power is 55. This gem glows bright pink under the Chelsea filter. This one. And fluoresces a strong pink under lone wave UV light. Fluoresces bright pink under the Chelsea filter. This one. And fluoresces a strong pink under lone wave UV light. Under the UV light also, it gives strong pink. See the three differences, both due to the cobalt, because of the cobalt. The lighter cobalt spinel on the right side, this one is lighter than this one. Then look at that. The lighter cobalt spinel on the right is less fluorescent and slightly more magnetic than that stone. The magnetic power here is 55. It is more, 73. SI level is 73. So this stone is more magnetic because of iron content is higher than this one. Less cobalt and high iron content is the reason. The two rough spinels, crystals pictured below, there are two rough spinels, are also cobalt spinels. Both are cobalt. The crystal on the left, this one, is weakly magnetic, and fluoresces bright red, suggesting high cobalt content. The slight purplish tone could be due to a bit of chromium, that means red, mixing with the cobalt blue. Although this is difficult to know for sure even with the spectrometer. The blue octahedron on the right fluoresces is pink rather than red. This is the crystal formation, the blue octahedron formation. Right, this one. Fluoresces pink under rather than red, suggesting less cobalt than the crystal on the left. And the octahedron is a little more magnetic, suggesting more iron. This is little more magnetic than this one. That means iron content is high there. Cobalt oxide is equally as magnetic as iron oxide. Remember, cobalt and oxygen gives cobalt oxide. And the iron and oxygen gives iron oxide, ferrous-ferric light. Cobalt oxide is equally as magnetic as iron oxide, but approximately 20 times less cobalt than iron is needed to produce blue color. Remember that. If you forget to subscribe, please subscribe and give shares. Natural cobalt spinel from Vietnam with saturated blue color contained only 1236 parts per million cobalt. This is scientific analysis gives 1236 parts per million cobalt gives inside the natural cobalt spinel. That means as a percentage 0.16%. It includes cobalt oxide. If we took parts per million parts, if we took million parts, cobalt there is 1236 out of 1 million. So that is the measurement, which would likely be high enough to create a weak magnetic response and perhaps contribute some portion to measurable magnetic susceptibility. Now these are the cobalt spinel colors. You can understand. All are Vietnam cobalt spinels, cobalt blue spinels. Now look at the colors. This is called cobalt blue spinel. In Sri Lanka, you can see a lot of cobalt blue spinels with the certificates, but those are not cobalt spinels. We discussed earlier. Go and read it again. That is the reason. Natural spinel that has diffused on the surface with cobalt has pure blue color like this. This is diffused spinel, synthetically created. Cobalt is diffused inside the stone. Natural spinel that has been diffused on the surface with cobalt has pure blue color like this and can look similar to genuine cobalt spinel. It is only look similar. Inside chemistry is different. And I like and like untreated cobalt spinel, cobalt diffuse spinel gems appear red under the Chelsea filter and fluoresce red under the long wave UV light. And like untreated cobalt spinel, cobalt diffuse spinel also both are same. It gives red color under the Chelsea filter and the red color under long wave UV light. Remember that. They also show a pronounced cobalt spectrum under the spectroscope. This is the spectrum of natural blue spinel iron. The gem shown below is weakly magnetic, most likely due to natural iron, as the amount of cobalt used in diffusion is very small. In this diffusion, amount of cobalt is very small, but inside the natural iron is more, so it is attractive. It attracts the magnets. Right. Now, treatments regarding the spinels. Like any gem, spinels that contain surface reaching fissures may have those fissures filled with a colorless or colored oil resin glass to reduce their visibility. That means filling. That is filling like rubies. There are some inclusions inside. So after this filling method, oil resin or glass, after filling, the inclusion visibility is reducing. So filled spinels, those are called glass filled spinels, like rubies. Filled spinels are becoming more and more common as the price of this gem increases. Natural spinels are very high, so price. So the filled spinels are becoming more and more common because of that. That is the treatment. Various reports have indicated that gem traders, not traders, treaters, gem treaters are experimenting with heating spinel to improve its appearance. Lot of treaters are trying with the heat treatment. As of 2012, only slight changes have been reported. Most of the change after treatment appears to be due to a slight improvement, only the small improvement in the clarity of certain specimens. It is not success yet. Heated spinels can be identified by reference to a broadening of the Raman line width at 405 centimeters. This is the spectrometer line at 405 nanometers. We can find this through the Raman spectroscopy by the R line width of fluorescence. Those are heated spinels. We can recognize. Join us, learn and enrich your future. We will meet with Spinel Part 4 in the next lesson 33. Please subscribe and give shares. We will meet on lesson number 33 next time.